Section 2.2, linear equations. Objectives are to graph a linear equation and to write the equations of lines. So graphing linear equations. A linear function is a function whose graph is a line. A linear equation is an equation that represents a linear function. Your independent variable is the variable that makes up the domain of the function. And remember that those are the values that you put into x, and the dependent variable is the variable that makes up the range of the function. And remember, those are the y values that you're going to use. So the domain is the x values, remember, and the range is the y values. Now, slope-intercept form, if you recall, y equals mx plus b. Your m stands for the slope, and your b is the y-intercept. So it's the y-intercept, and again, the y-intercept where the graph crosses. The y-axis, hence that's why it's called the y-intercept. So this right here would be the y-intercept. This right here would be the x-intercept, because that's where it crosses the x-axis. How do we calculate the slope? Remember, your slope is the rise over the run. And if you're given 2 points, so like right here we have x1, y1, and x2, y2, the way that you calculate that is y2 minus y1 over x2 minus x1. And remember, it's always rise over run, so in this case the vertical change and then the horizontal change. Let's go ahead and graph some of these. And again, this should be familiar to you guys. Okay, so we're going to graph these. Ignore the lines that I have right there. I'm going to use those for my graph so I don't have to worry about them later. So on our graph, remember that when we're graphing these, you do the slope and the y-intercept. So we have y equals 3/4 x. So our slope in this case is 3/4, and our y-intercept, our b, is equal to 0 if it's not written. So when you're graphing this, you start at your y-intercept, which is 0, and then you do your rise of the run. So we're going up 3 and right 4, which would be right here. So again, up 3, right 4. And then, of course, you would take your ruler. So you guys should out your ruler. And then you would connect the points with a straight line. And I just realized that that point was off a little bit, so it should have been right there. And notice that your line should go through your points. And of course, also notice that my line that I drew has arrows at the end of it. So let's go ahead and do the next one. Now for this one, notice it's not in slope-intercept form. If your line is not in slope-intercept form that you're given, you need to put it in the slope-intercept form. So subtract x from both sides, and you get y is equal to negative x minus 2. So that means that my slope is negative 2, and my y-intercept in this case, I'm sorry, my slope is negative 1, because that's what's in front of your x, and your y-intercept's negative 2. So in order to graph this, on my graph I start at my y-intercept, which is negative 2. And then I'm going down 1, because it's a slope of negative 1, right 1. Down 1, right 1, down 1, right 1. And then when I put my line on that, it should connect through all the points. And if you have these squares, you should always try to take your line so it goes through the entire graph. I don't want like little lines on your graph. So let's go to the next one. So for this next one, we need to do the same thing. So first you need to solve for y. So I'm going to add the 2. And then rewrite it. So if I rewrite this, I get y is equal to negative 4 thirds x plus 2. My slope is negative 4/3. My y-intercept is 2. So on my graph, I put 2 on the y-axis, and then I'm going down 4, right 3, and down 4, right 3. And so then I would take my ruler and connect the dots using my whole piece of graph that I have and arrows on the end. So again, that should be some review. Now let's go ahead and talk about the intercepts and standard form. So the y-intercept is again the point where the line crosses the y-axis. And to find the y-intercept, you plug 0 in for x and solve for y. So anytime you're finding the y-intercept, your point's always going to be 0, comma something. The x-intercept, again, is the point where the line crosses the x-axis. To find the x-intercept, you plug 0 into y and solve for x. So your point for this one is going to be some x value, comma 0. Now, we also have different forms for our lines. We talked about slope-intercept form. We also have standard form. So standard form for a line is ax plus by equals c. And remember, you're going to be plugging numbers in for a, b, and c. X and y always stay in your equation. Now, remember for standard form that a value cannot be negative. And also that you can't have any fractions. So if you have any of that, you need to manipulate your equation so that you do not. Now, for standard form, it's useful when you're graphing something and you want to use the intercepts if they're easy to find. So if we look at this equation that we have right here, let's find the x and y intercept and use those to graph. So if I want to, again, find the x-intercept, I plug 0 into y and solve for x. So the x-intercept, I'm going to do 3x plus 5 times 0 equals 15. So then negative 3x and 5 times 0 is 0 equals 15. So x would be equal to negative 5, and my x-intercept, that means, would be negative 5, comma 0. So I would put that in my graph. Negative 5, 0 means we're going to be right here, because it's the x-intercept, not the y-intercept, so you're on your x-axis. So then the y-intercept, we're going to plug 0 in for x and solve. So when I do this, I get 0 plus 5y, so 5y equals 15, so y is equal to 3. So then to write this as an ordered pair, we would have 0, comma 3, and again, this will be on your y-axis, so over 0, up 3. Those are my x and my y intercepts, and then I would take my ruler and I would connect the points with a straight line. And of course, don't forget your line continues on forever, so we got those arrows at the end. So that's how you would graph with the x and y intercepts. So let's go to the next one and do the same thing. So for this next one, why don't you guys try it, pause the video, and then unpause it, and we'll do it together. So for the, again, x-intercept, we're going to plug in 0 for y and solve. And notice that this equation is not in standard form, that's okay, it doesn't matter. So for the x-intercept, when you plug 0 in for y, you get 10 minus 3, x equals 7 times 0. So 10 minus 3x equals 0. So I'm going to take the 10 to the other side by subtracting it. And I get negative 3x equals negative 10. So x is equal to 10 thirds. So my x-intercept would be 10 over 3, comma 0. My y-intercept, we're going to plug 0 in for y, 0 in for x and solve. So 10 minus 13 times 0 equals 7y. So 10 and 13 times 0 is just 0, equals 7y. Divide both sides by 7. and we get y is equal to 10 over 7. So I get 0, comma 10 over 7. So now this is a case where graphing these intercepts really isn't that nice. So it probably would have been better to put this in slope-intercept form and then graph my line, but that's okay. So the best way to graph this is probably to figure out what the decimal is for each of these. So 10 thirds is about 0.77, and 10 over 7 is about 1.4. So on my graph, if we do this, we have so 0.77 on the x-axis is very close to 1. Oops, that looks like I just put it at 1, so very close to 1. And on the y-axis, we have 1.4, which is almost swoops in the middle. It's hard to make those small dots with my line. So then I would take my ruler and connect those two dots that we have. So it looks something like that. My points were a little bit off because it's hard to do on the smart board, but you get the idea. So that would be what my line should look like. And of course, hopefully you guys know how to graph lines in your graphing calculator. So if I wanted to, I could put this in slope-intercept form and then put it into my y equals in my calculator. We'll go ahead and talk about doing that later. Now for the next part, we're going to talk about slope and writing linear equations. So to find the slope, we already talked about y2 minus y1 over x2 minus x1. If it helps you to write the numbers on top, that's fine. So this would be x1, y1, and this would be x2, y2. So my slope is equal to y2, which is 2, minus negative 2, over 4 minus negative 2. When I do that, I get 2 minus negative 2 would be 2 plus 2, over 4 plus 2. 2 plus 2 is 4 over 6, and 4 over 6, of course, reduces into 2/3, so that's my slope. For the next one, we can do the same thing, except for we have different points. So 5 minus 5 over 7 minus negative 6, which gives me 0 in my numerator, over 7 plus 6. So in this case, we would end up with 0 over 13. And remember, 0 in your numerator is okay, we just can't have it in our denominator, so this is just equal to 0. So my slope is 0. Remember, when we have a slope of 0, we have special lines, so this is actually going to be a horizontal line. And for the next one, we have finding our slope, so you should try this on your own, pause the video, then unpause it, and we'll take a look at it. So 6 minus negative 7 is 6 plus 7 over negative 8 minus 2. So we get 13 over negative 10. And then for the last one, we would get a slope of 17.5 minus negative, so plus 12.5 over negative 3 minus 3. And if you look at your denominator, you have negative 3 minus negative 3, so that should have been plus. Negative 3 minus 3 is equal to 0, and we can't have 0 in my denominator. Doesn't matter what's in my numerator. So because of that, I know that my slope here is undefined. And remember, when you have an undefined slope, this is a vertical line. So now let's talk about equations of lines. So again, we have the last equation that we didn't talk about, which is point slope form. So it's the line that goes through the point x1, y1 would be the equation y minus y1 equals your slope times x minus x1. And for this, you always would keep your x, your y, and your slope. What's going to be changing is this x1 and y1 point. Slope-intercept form, we said, was y equals mx plus b, and standard form ax plus b, y equals c. Now, for this next part, we're going to write an equation for the line with the given conditions. So for this first one, we have m equals 1/5 and passes through negative 5, 8. So if we want to write the equation for this, the first thing that would be easy to use would be point slope form, because we have a point and a slope. So So I always like to write out the equations because it helps me memorize them. Y1 minus y1 equals m times x minus x1. So when I plug that in, I have y minus 8 equals 1/5 times x minus -5 becomes plus 5. That would be point slope form. If I wanted to put this into slope intercept form, I would have to solve for y, so I would distribute the 1/5, so I get y minus 8 equals 1/5 times x, and then 1/5 times 5 would just be 1, and then add the 8, and y would be equal to 1/5 x plus 9, so this would be slope-intercept form. And then, of course, the last one, standard form, is the form of ax plus by equals c. So notice your x and y are on one side and your constant is on the other. So for this equation, we would have to subtract the 1/5 x to the other side. So when I do that, I would get negative 1/5 x, and I put the x first because it's ax plus by equals c, plus y equals 9. Now remember, we said when we are writing equations in standard form, we do not like to have negative a value, which we have, and we also don't like to have fractions. So how do I get rid of that negative? I would multiply everything by -1. How do I get rid of that 5? 1/5, I would multiply everything by 5. So basically what that means is I'm multiplying both sides by -5. So -5 times -1/5 would be, positive 1x, so I just write x. -5 times +1 would be -5, and then we have that y there. And then -5 times the 9 would give us 45. And so this would be my equation if it were written in standard form. And I just noticed that I forgot because this is -5 times +9, so that's negative. So that would be my standard form. And so I just shrunk all those and put them underneath the equation. So the next part for B says we're going to write the equation in a line that passes through 5, 0, and -3, 2. Well, if you look at for point slope form and slope intercept form, in order to write the equation, you need to find the slope first. So that's the first thing you're going to do here. So slope would be equal to 2 minus 0 over -3 minus 5. So we get 2 over -8, which is equal to -1/4. Now that I have my slope, if I want to write the equation of the line, next I would need to put this into point slope form. So if you look, you have 2 points here. How do you know which one to pick? Really, it doesn't matter. So you can pick either of the points. So pick either point. And in this case, I'm going to pick the one with 0 because 0 is easier to work with. And then I would always write it down so I know which one you picked. Now I'm going to put this in point slope form. So y minus 0 equals my slope times x minus my x coordinate of the point that I'm using. Now this would be point slope form. If I wanted to put this in slope-intercept form, I would just need to distribute that 1/4. So slope-intercept form would, of course, be y equals mx plus b. So when I do that, I have y minus 0, which is this y, and distribute each of these terms here. So when I do that, I get -1/4 x, and negative times negative is positive 5/4. So that would be my slope-intercept form. And the last form, let's do standard. So remember, ax plus by equals c. First, I need to get the 1/4 to the other side by adding it to each side. And of course, here I don't like fractions, so I have 4 in my denominator, which means I need to multiply both sides of my equation by 4, not -4 because my a value is positive. I don't have to worry about that negative now. 4 times a fourth would give me 1x plus 4y equals 5. So again, all I did was distribute to each of the terms that we have right there. And this right here would be, of course, then my standard form. And normally in problems, you wouldn't have to probably do all 3 of these. However, it would tell you which form to use. So however, we're just practicing each of the different forms. So for this next one, we have m equals 3/2 and b equals 5. So the easiest would be slope-intercept form because you have your m and your b. So y equals -3/2 x plus 5. And if I wanted to put this in point slope form, I would have to figure out a point on my own by either putting it into my graphing calculator or by just picking a point for x and plugging in and seeing what I got out for y. That would be fine too. And if I wanted to do standard form, so this is slope-intercept. If I wanted to do standard form, I would take the 3/2 x to the other side. I would get 3/2 x plus y equals 5, and then I would multiply both sides of my equation by 2 because I want to get rid of that fraction. So I would get 3x plus 2y equals 10 because you have to distribute to every term in your equation. So this would be the standard form. And the next one says we want to find the slope of this equation. If I want to find the slope of this equation, pretty easy to do. You just have to solve for y and put it into y equals mx plus b, so slope-intercept form. First thing I would do is add the 2x to the other side, so -3y equals 2x plus 15. Then I would divide everything by -3. And we get y is equal to -2/3 x minus 5. So that means the slope is equal to -2/3. The very last thing that we want to look at are horizontal and vertical lines. So that would be the last thing that we're going to talk about. And just as a reminder, horizontal lines look like this, and it's y equals some number. They have a slope which is 0. And vertical lines here go like this way, and it's your slope's undefined, and x is equal to a constant. The way that I remember that is I use this little device called Hoy-Vux. So this H stands for horizontal. 0 just stands for 0 slope. And y equals. For the other part, V stands for vertical. U stands for undefined. Slope. And x equals some number. So you don't have to use that, but that's how I remember it. We will talk about perpendicular and parallel lines a little bit more tomorrow as well, but just to quickly look at it, remember perpendicular lines will intersect at 90-degree angles. Also, perpendicular lines, these slopes are negative reciprocals of each other. So if you have a slope of 1/2, remember that's the sign for perpendicular we learned in geometry, the perpendicular slope is equal to -2 over 1 or just -2, etc. And for parallel lines, you have the same slope but different y-intercepts. And again, we will be doing some practice of this tomorrow. So just bring this with you to class.